Okay, here's the second part of the video on moles. Now, mole problems have to deal with the amount of things. And if I were talking about 12 things, I would refer to it as a dozen. So we're all familiar with the dozen equals 12 things. Well, in chemistry, we talk about moles is equal to a number of representative particles. A representative particle could be an ion, an atom, a formula unit, which would be an ionic compound, or a molecule. So any one of those fours we can refer to as representative particles. Now, if I have a mole of sodium chloride, that mole of sodium chloride would have a different mass than a mole of water or a mole of calcium carbonate because they each have different molar masses. So the last lecture video, we talked about sodium chloride weighs 58.5 AMUs because I added up sodium and chlorine to get 58.5 AMUs. Well, now I can change the AMU to mean that if I put a mole on the scale, it would have a mass of 58.5 grams. Just like if I had a mole of water, it would be 18 grams on the scale. And then calcium carbonate would be 100 grams. Another label could be just grams per mole. So down here, the molar mass of sodium chloride is 58.5 grams per mole. That means 1 mole of sodium chloride has a mass of 58.5, just like water, 18 grams per mole, and calcium carbonate, 100 grams per mole. So let's dive into the first problem. Example 1. If I had 200 grams of calcium carbonate, how many moles is this? Step 1, I have to write a formula for calcium carbonate. Calcium is Ca plus 2, carbonate CO3 negative 2. Because they're opposite charges, I can cancel those out, and calcium carbonate is CaCO3. Step 2, I would look on the periodic table and find the molar mass for that. There's 1 calcium at 40.1, 1 carbon at 12, and 3 oxygens at 16. So when I add those all up, 40.1 plus 12 plus 3 times 16, I get 100 grams per mole. That means if I had a mole of it, the mass would be 100. Now, using dimensional analysis, step 3, start with the 200 grams. Now, some of you are saying, I can do this much easier in my head. I know if a mole has 100 grams, then 200 grams would be 2 moles. But we're going to show this dimensional analysis. This 100 grams per mole is an equivalence factor. It means 100 grams equals 1 mole. So DA, I put my grams on the bottom to cancel out, moles on top. 1 mole equals 100 grams. Cancel the grams. 200 divided by 100 is 2 moles. Okay, if you think you get this, try to stop the video and do the next 3 problems, or 4 problems. Okay, so let's go for example 2. If I have 28.7 grams of lithium nitrate, how many moles? Step 1, write a formula. Lithium is a plus 1, Li plus 1. Nitrate is NO3 negative 1. Therefore, the symbol is LiNO3. Step 2, calculate the molar mass based off the periodic table. I have 1 lithium at 6.94. I have 1 nitrogen at 14. And I have 3 oxygens at 16. So when I do the math on that, 6.94 plus 14 plus 16 times 3 is 48. That's going to be 68.9 because of 3 sig figs grams per mole. Okay, step 3, set up our DA equation. So I start with what's given, 28.7 grams of lithium nitrate. I know the equivalence factor is 68.9 grams equals 1 mole. So ask yourself, if I had a mole, it would be 28.7 grams. If I had a mole, it would be 68.9 grams. Because I only have 28.7 grams, I know I have much less than a mole. In fact, I have less than half, and I should have 0.417 moles. Okay, step 3, or example 3. Nitrogen is in 2. So I have 2 nitrogens at 14, or the molar mass of nitrogen is 28 grams per mole. That was step 1 and 2. Step 3, I'm going to set up my DA problem. 100 grams of nitrogen. I know that for every 1 mole of nitrogen, it's 28 grams. Now, ask yourself the same thing. 1 mole would be 28 grams. 100 would be much more than a mole. In fact, it is 3.571. The reason why I have 4 sig figs is because the 100.0 was 4 sig figs. All right, stop it if you still didn't try this and see if you can do the next one. Now the next one is water. Water is H2O. And the molar mass of water is 2 hydrogens at 101 plus 1 oxygen at 16 is 18.0 grams per mole. Now I set up my DA problem. 1.34 moles. Would I put the moles on the top again? No, I'm going to put those on the bottom. So that's 1 mole equals 18 grams. Moles cancel. Ask yourself, if 1 mole is 18 grams, 1.34 would be over 18 grams. In fact, it is 24.1 grams. Last one. Try it. Make sure you try it by yourself. Now, carbon dioxide, CO2, molar mass. Carbon is 12. And 2 oxygens at 16 equals 44 grams per mole. Step 3, I'm going to write a DA problem. 12.169 moles in a fire extinguisher. I'm going to convert that to grams. 44 grams over 1 mole. Moles cancel. I'm going to have a whole lot of grams. In fact, 535.44 grams. The reason why I have 5 sig figs is because 12169 is 5 sig figs. Okay, that completes mole conversion.